All right, so it is day 5, um, and the thing is going to start in like 30 seconds. So I think yikes, let's zoom in. I have a day5.py, I have a day5.text, I have a, let's just quit out of that and run advent 2020 day05.py. That works. Okay, we're in good shape. And here we go. Let's see. Binary boarding. I like binary. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all the flight attendants are busy with the flood of people that's only made it through passport control yesterday. You write a quick program to use your phone's camera to scan all the nearby boarding passes, your puzzle input. Perhaps you can find your seat through process elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. So you might be specified like F, B, F, B, front, back, left, right. The first 7 characters will be either F or B. These specify exactly one of the 128 rows on the plane. Each letter tells you which half of the region the given seat is in. Start with a whole list of rows. The first letter indicates which seat is in the front or back. The next letter indicates what half, and so on. For instance, consider just the first 7 characters of this. F means take the lower half. B means to take the upper half. F means to take the lower half. Final F. The last 3 characters will be either L or R. These specify exactly one of the 8 columns of seats. The same process as above proceeds again, this time with only 3 steps. L means keep the lower half, while R means keep the upper half. Consider RLR. R means upper half. L means lower half. Every seat also has a unique seat ID. Multiply the row by 8, then add the column. In this case, the seat has this ID. There's some other boarding passes. Okay, look through the list of boarding pass. What is the highest seat ID on a boarding pass? Okay, so that seems pretty straightforward. And let me do this. Okay, so you knew I was going to do this important name tuple. And so class seat, which is a named tuple, is going to have a row, which is an int, and it's going to have a column, which is an int, and it's going to have a property, calculated property, which is going to be a seat ID, which is going to be an int. And what was the reasoning? Multiply the row by 8 and then add the column. So return self.row times 8 plus self.col. Okay, good. And then what we want to do is we want to find seat from, I'll call it BP for boarding pass because I don't want to have to type out boarding pass, and that's going to return a seat. And now we said the first 7 characters are going to be in binary, and F means 0 and B means 1. Okay, so BP, or let's say, okay, watch this, equals 2 to the I times 1 if, this is going to be even better. What did I say? B means the upper half, and F means the lower half. So B1 F0, and 2 to the I is wrong. Actually, this will work. For IC in enumerate, reversed BP, and we want to say 7. Okay, so this is like me like showing off and being a jerk. And then the last 3 will be L or R, and R is 1. And so call equals 2 to the I, and I think I said R is 1 and L is 0. C for I, C, and enumerate reversed BP minus 3. Okay, so this is such a jerky thing to do. Return seat row call. What? Yes, because I want to sum this up, and I want to sum this up. Okay, and so let me just do one of these and see if it works. Seed equals row 148, column 14. So that's not right. Good. Let's figure out what I did wrong. That's what I get for not really thinking this through. This is BFF, so that's this one, row 70, column 7. Okay, so first off, the column can't be 14. That's a huge problem. So let me get rid of that reversed. Enumerate BP 7, and then I'll think about what I need to add to that. And actually, I may have done something really stupid, which is as follows. What if I just do that? I don't know if the precedence. And enumerate. Let's try this one more time. 140, column 14. Okay, so that's still completely wrong. In fact, it's potentially even worse. So, this is what I get for trying to be too clever. And 6 minus I, and let's do 2 minus I, and see if that does this any better. If not, I'm just going to start over. Okay. Let me go back and reread the problem, because it's possible that I read it wrong. 0 to 63. What did I screw up here? So if it's R that I want to put 60, or sorry, if it's B, I want to, all right, well, let's just work this out. Row equals 0, call equals 0, for C, for I, C, and enumerate BP for 7, and did I do that right? For 7, yes. Multiplier equals 2 to the, let's say, 6 minus I, and include is if it's a B. So let's say include equals 1 if C equals B, else 0. Row plus equals multiplier times include. Okay, and now I'll do the same thing for IC and enumerate BP minus 3. Here the multiplier is going to be 2 to the 2 minus I, so it'll be 210. Include equals 1 if C equals R, else L, and call plus equals multiplier times include. All right, let's see if this is any better. Row 70, column 7. That seed ID is 567. Okay, so that's good. And I don't know. Find seats of row 14, column 7, and find seats of this guy. Plus equals. Interesting. Else 0. Row 102, column 4, and let's check its seed ID. 820, so that seems good. So as sanity check, you look through what is the highest seat ID in your boarding pass. So let's copy this and put it here, and say with open, say inputs day05.text as f seats equals find seat BP for and also always I'm going to do this defensively for BP and F, and print max of seat dot seat ID for seat in seats. Okay, so let's run that and see what happens. It says the maximum is 896, so let us try that. That's the right answer. Dating the fastest seatbelt signs are turned on, time to find your seats, complete full flight. Your seats should be the only missing boarding passenger unless there's a catch. Some of the seats at the very back of the plane don't exist in the aircraft, so they'll be missing from your seat as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from yours will be in the list. So what is the ID of your seats? So in other words, we want to find a gap. Let's please full flight seats are the only missing boarding passenger list. However, there's a catch. Some of the seats. Okay, so seat IDs equals seat dot seat ID for seat in seats. And then print X for X in seat ID. No. Let's do low equals min of seat IDs, high equals max of seat IDs, and print X for X in range low high if x not in seat IDs and x minus 1 in seat IDs and x plus 1 in seat IDs. So we'll take the lowest and highest, look for all those, and then find someone who's not there, but who one before him and one after him is there, which I think is what they said. 659 is my seat ID. So let's put that in. All right. So so this was not a super hard problem, but I solved it wrong by trying to be too cute. So that's a good lesson for me, not to be too cute. So what did I do, and what did because I sort of looked at the problem and saw what it was pretty quickly, even if I screwed up the solution for it. Um, so, sorry, I'm having a lot of trouble with this computer today. Right. So, I mean, they tell you binary space partitioning, but when it says consider these F, B, F, F, R, F means take the lower half, B means take the upper half, F means take the so on, right? Um, that's exactly how binary works, where 1 means take the upper half and 0 means take the lower half, right? So if you just take these first 7 and you treat the F as 1 and um, and the B's is 0. So what I really should have done is something like this. This would have been clever. One if C, so again, I want to do like B to 1 and F to 0, C for C and this, right? So if I do that, I get a binary. And now if I wanted to do them as strings, I could do that, and then do like join them. Okay, and now I can do int of this in base 2, which would tell me that it's 44, which I think is 44, right? So that this would be kind of this is really like a much slicker version if I just put it in there. Why is this doing this? I don't want to do interpreter path. So watch this. Find seat 2 of a boarding pass, which is a string, and is going to return a seat. And I didn't copy the thing I wanted to copy, which is so this one will be awesome. That basically what we want to do is we want to say row equals int of that join of and maybe I don't need to do this anymore. And then column is, and now instead of doing this, I'll say BP7, and call is going to be int our start join of I think it was R1 L0 C for C and BP minus 3 to and return seat row call. So that's like a really cutesy one-liner way to do it. Um, and now I could do find seat 2, and um, if I run that one, we'll see if I get the right answer. And so I get the same answer, right? So anyway, that's all right. That was a digression because I wasn't really explaining it. But anyway, this is exactly how binary numbers work. If you see like, so if you think about 7-digit binary numbers, they go 0 through 127, where all zeros is 0 and all ones is 127. And if you look at the first digit, if it's a 1, then that means it's in the top half of the range, so that's like a B. And if it's a 0, that means because that's the 64 place basically. And so if that's a 1, you add 64 to the number. If it's not, you don't. So front half, back half. And then the next one is, front half of that or back half of that. So this is exactly how a binary number works. And it's just a matter of turning these things into zeros and ones, and then turning those zeros and ones into binary numbers. Um, so I'm a little bit sad I didn't come up with this one to start with because it, it's impenetrable and awesome. And then the other thing was that they said basically now look for a missing seat number. Well, how are you going to find a missing seat number? The easy way to do it, or the way I did it anyways, find the lowest seat number, find the highest seat number, and just go through all of them and say what is the seat number where it's missing, basically. And in fact, I probably didn't even need to. I bet I didn't even need to check this. I probably could have just done. If X not in seat IDs, and I bet that might have worked too because they said it's missing at the front of the plane. So if I take low and high, that still works. So yeah, that's it. So like I said, there was a bad attempt that I was trying to be too clever with bit shifting operators, and I should not have done that. Note to self: do not try to be clever with bit shifting operators because you're not that clever. And but yeah, we got solved. All right, cool. That's it. I'm gonna call it a night. It's been a long week. So see you next time.